Section 1.6, we're discussing absolute value inequalities. So let's look at an example of a less than and a greater than to understand what this means. We talked before about how absolute value means that you're looking at the distance between a number and 0 on the number line. If we're asked to find the absolute value of x less than 3, we're looking at all values of x that are less than 3 units away from 0. Okay, less than 3 spaces or 3 units from 0. Okay, well here's 0. 1 is less than 3 spaces from 0. Negative 1 is less than 3 spaces from 0. Okay, 2 is less than 3 spaces from 0. Anything up to 3 is going to be less than 3 spaces or less than 3 units from 0. All the way up to negative 3 and positive 3. Or I guess I should put you might be used to the open circle. I tend to put parentheses, but it means the same thing. So anything between negative 3 and positive 3 is going to be fewer than 3 spaces away from 0, so it would solve the inequality. So negative 2 would solve it, negative 1 would solve it, 0, 1, 2, and all the decimals and fractions in between. So how would I write what I've graphed as a solution? You could also think of it as the open circles, everything in between shaded. To write that as a solution, I'm looking at all values of x that are between negative 3 and positive 3. So I could write it as negative 3 is less than x and x is less than 3. I can write it as a, we call that a sandwich inequality or a 3-part inequality. So that's the way if you've got an absolute value of something less than a number, your solution is going to take this form, where it's going to be the opposite of the number first, less than the inside of the bars, and then that has to be less than the positive of the version here, or the number here. What if you've got the absolute value of something greater than a number? So here, absolute value of x is greater than 2. So that means I'm looking at numbers for x that are more than 2 units from 0. Okay, so negative 1 is not more than 2 units from 0, but negative 3 is. So negative 3 is part of my answer. Negative 4 is more than 2 spaces from 0. Positive 3 and positive 4, those are both more than 2 spaces from 0. Anything bigger than 2 would satisfy that. Also, anything smaller than negative 2 would satisfy it. So all of these values back here. So for my answer, I would say x is less than negative 2, or x is greater than positive 2. Both pieces are necessary for my answer. I have to say both. So anytime you've got absolute value of a variable or absolute value of something greater than a positive number, the greater here is telling me that it's got to be 2 separate cases. Okay, so it's very important to pay attention to whether you have absolute value greater or absolute value less than. And now we'll look at some examples. So this is straight from your notes, absolute value inequalities. I'm going to do example 1. It says solve and graph the solution on a number line. I have absolute value of 2x plus 3 is less than 6. And I've also got a number line to use. Okay. So, because this is an absolute value less than, I know that it needs to be in this format. So it's going to be the opposite of the constant. So we're going to set it up as negative 6 less than the inside of the bars, so 2x plus 3, less than 6. And then we're going to go through solving this for x. I don't know if this is something that you've done in the past, but it's really not difficult. If you just look at this much by itself. If you've got 2x plus 3 less than 6, then we know that we would start by subtracting 3 on both sides. Because this inequality has 3 parts, we'll do it to all 3 sides. So subtract 3 on all three sides. That gives me negative 9 less than 2x. 3's cancel, and that's less than 3. Okay, and then I still have to get x by itself, so if I had this, I would divide everything by 2. So we'll do that here. Divide all three sides by 2. So I have negative 9 halves less than x less than positive 3 halves. And then I'll go to my number line. Negative 9 halves, you can think of that, that's negative 4 1/2. Okay, so 1, 2, 3, 4. I apologize, my number line is not very even. 1, 2, 3, 4. Negative 4 1/2 would be here. I'm going to put an open circle. And this is telling me to shade everything between negative 9 halves and positive 3 halves. Positive 3 halves would be 1 1/2, so about right here. I'll put an open circle. And I shade in between those two values. Because x is between those numbers, my graph will is also between those numbers. And then I can give my answer. Well, this is the solution right here. And this is the graph. Example 2. Example 2, we have solve and graph the solution on a number line for absolute value 2x minus 3 greater than or equal to 5. Okay, so we have absolute value greater, so this time it's going to be two separate cases separated by the word or. So you're going to say, you'll drop the bars for your first case, so you'll do case 1. 2x minus 3 is greater than or equal to 5, or drop the bars, 2x minus 3. And this time, if you look at, go back and look at the example we did before. This was our basic absolute value greater than a number. We dropped the bars for the first case to get x is less than negative 2. Excuse me, I'm sorry. We dropped the bars here to get x is greater than 2. And over here, we dropped the bars, but then we actually ended up flipping the inequality and taking the opposite of the constant. So that's what we're going to do here as well. One case, we just dropped the bars. Second case is going to be the inside. We'll do less than or equal to negative 5 because it's got to be on these outer edges of your number line. So greater this way, less than or equal to the opposite of the constant this way. And that's what we have. So add 3 to both sides. We have 2x greater than or equal to 8. So x is greater than or equal to 4. Over here, add 3 to both sides. 2x is less than or equal to negative 2. Divide both sides by 2. X is less than or equal to negative 1. So we've got two different pieces to our answer here. And then we're going to graph that. If you've got two separate inequalities, then your graph is probably going to have two separate graphs inside it. Okay, so x is greater than or equal to 4, so go to 4, put your closed circle because it's equal, shade to the right, everything greater. Second case, find negative 1. You're going to do a closed circle at negative 1, shade everything less than to the left. Okay? And then your final answer, you'll just say x is greater than or equal to 4 or x is less than or equal to negative 1, and that's it. There are some special cases that can come up. And this is going back to your notes. So if we'll go back and look at that, at the very bottom of the first page, it states that, sorry to have to jiggle the camera so much, it states that special case number 1, if you've got the absolute value less than a negative, okay, so let's draw what that looks like. If the absolute value is less than a negative, or actually, let's just think about what it means. We know that absolute value is always positive because it means the distance, you're measuring distance with absolute value. So an absolute value less than a negative, there's nothing to graph on your number line because since your absolute value is always positive, you cannot have a positive less than a negative. That's impossible, so that would be no solution. In case 2, we've got absolute value greater than a negative. Okay, well this one, absolute value is always positive, and we have positive greater than a negative. This is always true, and because it's always true, we're going to say that it's infinite solutions. Okay, so anytime we have, after we isolate the absolute value, pay close attention to what's left. If you've got the absolute value less than a negative, that's always going to be no solution, and an absolute value greater than a negative is always infinite solutions. So just pay attention to that. And we're ready to do some examples. All right, so we're going to look at part A. Absolute value -9 plus p plus 5 is less than 24. I'm going to do that on another page because I don't know how much space I'm going to need for it. Okay, so absolute value -9 plus p, and on the outside plus 5 less than 24. So just like we did at the beginning of this section, we always start by isolating absolute value. Subtract 5 on both sides. Absolute value of -9 plus p is less than 19. And now you have to think about which case you have. You've got absolute value less than a constant. So that means that because it's less than, you're going to do the opposite of your constant. Less than the inside of the bars, less than the positive constant. And when you graph, you're going to be shading in between the two values. And now we need to get p by itself, so we're going to add 9 to all three sides. -19 plus 9 is going to give us negative, I'm tired and I can't think. -9 plus 10 would be 9, so this would be just one of those days I can't think straight. Okay, -10 is less than p, less than 19 plus 9 is going to be 28. So -10 less than p less than 28, and then I can graph that. I'm going to count by 5s. Okay, so I need to shade everything between -10 and positive 28. And because there's no equals with my inequalities, I can use an open circle at -10 and an open circle at 28. And I need to shade everything between those values. Okay, so that's the graph and that's the solution. All right, part B. Part B, we have absolute value 7 minus x plus 2 less than or equal to 12. So I start by isolating the absolute value. Subtract 2 on both sides. Absolute value of 7 minus x is less than or equal to 10. This is absolute value less than, so you're going to do the opposite of your constant. Less than or equal the inside of the bars. Less than or equal to positive of the constant. And now you're going to solve for x, so we'll subtract. If I cover this up, I can see I need to subtract 7 on both sides. So subtract 7 on all three sides. That gives me -17, less than or equal to -x, less than or equal to 3. All right, but I've got a negative 1x and I need to have a positive 1x. So to fix that, I need to divide all three sides of this by negative 1. All right, now from your work before, you should remember from Math 1 and Math 2, anytime you multiply or divide an inequality by a negative, you have to remember to flip those inequality symbols because it's changing the truth value of it. Okay, so when multiplying, just make a note if you need to. When multiplying or dividing by negatives, we flip the we flip the inequality symbol. Okay, so we're going to have positive 17 greater than or equal to x greater than or equal to positive 3. Okay, then when I go to graph this on the number line, it doesn't feel right. The reason is because the number line goes from smaller to bigger, left to right. So I'm having to flip things around. Okay, I don't like having to read it backwards like that. I want the smaller number first and the bigger number last. Okay, now if I read this from backwards, I can read this as 3 less than or equal to x less than or equal to 17. Okay, and if you get confused by that, you can always just cover up the x and ask, okay, is 3 less than or greater than 17? 3 is less than 17, so it's going to be less thans. These symbols are always going to be going in the same direction. They're going to agree. So x is between 3 and 17. Now it looks a lot better. I can graph it. I'll go to the 3. Because it's got the equals, I'm going to do a closed circle this time. 17 also has equals, so we'll do a closed circle. Shade in between. So that's what my graph looks like. And that's what the solution looks like. Now, you probably, if you're asking if this is correct, it is, but this is better. So I would give you full credit for this answer, but if it were multiple choice, you wouldn't see it. It would look like this. Okay, next question. I'm gonna find it. Okay, part C. Part C is absolute value 5 minus x plus 4 greater than or equal to 9. Okay, so I'm going to start by isolating the absolute value. I don't really need that anymore. So isolate the absolute value first. Subtract 4 on both sides. Absolute value of 5 minus x is greater than or equal to 5. This time I have the absolute value is greater, okay? That means that you're going to use an or statement. And you can think of the silly phrase greater to help you remember that if you see absolute value greater than, you need to do 2 separate cases separated by or. So you're going to say the inside, 5 minus x, greater than or equal to 5, or the inside, 5 minus x, less than or equal to negative 5. So flip that and take the opposite sign of the constant. And then solve. So subtract 5. Negative x is greater than or equal to 0. Divide both sides by negative 1. And you get positive x is less than or equal to 0. Over here you can subtract 5 on both sides. Negative x is less than or equal to negative 10. Divide both sides by negative 1. So positive x is greater than or equal to positive 10. So this is what the solution looks like. Got the or statement between it, and when we graph it, more than likely it's going to have 2 separate chunks, two individual graphs. All right, so 10 is going to be closed circle at 10 because it has the equals. Shade everything bigger, and then go to 0. Closed circle at 0 because it has equals. Shade everything to the left. So that's what the graph would look like for that problem.